Greetings, fellow nerds, and welcome to another episode of Between Two Nerds with me. I'm Jeff Doyle, and with me is my friend and co-host, Jeff Tansura. And we've got, you can probably tell from the names, we've got an all-Jeff show today. Hi,
So
Jeff.
everybody can make a wish.
Hopefully 3 Jeffs agree. We'll find out.
That's right.
So good morning, good afternoon, wherever you are. Jeff, great to see you. Jeff Haas, great to see you too. We all have known each other for, 20, 30 years. So again, it's friends all together. And without further ado, we will let Jeff to kick on and start talking about what BGP holds for us in the future, his view, and there are very few people who are more qualified than Jeff to talk about it. So please go ahead.
Yeah, I'm excited about that too because I've been asked. I've written a book with BGP in it, and I get asked for years and years. Well, is BGP ever going to be replaced? It's a really old protocol, and what does the future hold for BGP? So I'm really interested to hear your views.
Thanks. So this is partially based off a talk I gave a few weeks back at Juniper has co-hosted a event called the Nordic Tech Club. This was basically at the start of May. And the nice thing is, this was my first chance to get some level of international travel since the pandemic hit, and had a nice receptive audience. The structure of the talk I gave was sort of the same as a little bit what I did for a presentation a few years back for the NLNOG. They were looking for like a history of BGP, and this was sort of a good chance to maybe take that as a extension of that talk. And a good chunk of the discussion was, effectively, why has BGP been successful? The future is really about where BGP is sort of gone over its lifetime. BGP came into existence as BGP-4 back in 1994 after going through a couple different versions, and you'd think that 20 odd years later you'd be done with the protocol. There's nothing else to add. There's nothing else to take away. And as we see, not only from stuff that happens in IETF and the IDR working group where BGP gets standardized, but other working groups like BES, GROW, and other places, people are clearly interested in adding new stuff to BGP, and sometimes it's great ideas, sometimes it's bad ideas, and exactly what you think about it depends on what you're trying to do with the thing and where you happen to live in the network. And so a big part of the talk that I gave was, getting there was about the things that were successful about BGP. And, we're not going to deep dive into packet diagrams or anything like that, but the things that are generally successful have been that BGP was made to be incrementally extensible. Theoretically, you had a version number you could bump up if you decide to change things, but we've been at BGP-4 since 1994, so that bit of machinery just really hasn't gotten made use of. And we got capabilities, we got the ability to stuff IPv6 and then later VPN stuff in there, and we just kept on throwing more and more hacks on top of the encodings, and for the most part, it's worked out for us. The encodings let us add on new things. We had a lot of success with the fact that path attributes were a very early feature of BGP, very early in its design cycle. The idea with it they could be transitive or not was sort of initial bit of idea about the extensibility. Do these things make sense on boxes that know what to do with them versus don't? And for the most part, we saw this sort of slow and steady growth for the first couple of years of features that added path attributes. So we got things like features to scale up BGP sessions, like confederations, route reflectors, and that was the slow and steady things. And communities was the first thing that people added that were a general way to start using policy to start biasing route selection. So that sort of epitomizes the early portion of the process. We added things slowly. They got deployed. We had some crashes that knocked over portions of the internet as we got things wrong. And part of the question eventually became, as we're incrementally extending things, what happens to the blast radius of this stuff? back in the early days, BGP was run by a loose association of very tightly couple of people. There are small number of operators, small number of networks, and when something went kaboom, well, it was bad, but it wasn't horrible. But people obviously depend on this stuff for their business these days, and people get very cranky when they can't watch their streaming video. So people notice outages. So a lot of the tolerance we've had has steadily gone down over the cycle. So we had a big bump a few years back, motivated by an explosion from a bad path attribute that gave us error handling procedures that were a little bit better. And as we started seeing things, packet encoding issues haven't completely gone away, but they've gotten a lot rarer. The blast radius of those has gotten contained, doesn't take down huge portions of the internet. So the ability to incrementally deploy things has gotten better. But the same set of incidents also sort of made people more hesitant about BGP in the broader sense. What if you're sending me a thing that I'm not interested in? So you're starting to see people also trying to firewall these new BGP attributes and sort of making it harder to incrementally deploy things. So we have a nice tension of new stuff coming in, the encoding issues hopefully being contained by the error handling features, and we start getting more and more trends of how do we actually limit the blast radius on various things, because a lot of the things that we see that go awry end up being basically scoping issues. Either routes that are leaking past where they need to, or sometimes it's some feature that's intended for one purpose is sort of escaping from where it's intended to go. And we're starting to see a general surge, not only in IDR but just sort of IETF as a whole, about how far do things need to actually go. And that's I think sort of aiming the new piece of the conversation.
I'm kind of interested. You made some references to it. Is BGP just still in? We always kind of talk about it roughly as being the language of the internet. But is that the case that BGP is still, quote unquote, the language of the internet because it's so entrenched that it's pretty much impossible to pull out? Or is it more that it still does the job easily and efficiently? It's so easily, going to what you said, so easily extendable. And something I've said forever about BGP is that the protocol itself is really simple. It's the policies that you associated with it that are complex.
Yep. Yeah, and what I usually tell people when I'm giving talks is BGP is a simple protocol. BGP is about policy, and policy is all about money. So really, BGP is just a protocol for routing money. But the things you're sort of saying are part of that scoping, part of that blast radius, part of that extensibility discussion. The internet case is still the one that generates the most interest. If you go onto IDR, whenever anything gets contentious, it's usually because there's a small portion of the elders of the internet that are very concerned about, don't put things into BGP that could break the internet. And that's a completely worthy perspective to hold, and something that absolutely has to be taken care of. But we've also had BGP grow well beyond just internet use cases. VPNs are a very popular feature. BGP carries things like link state. If you're trying to actually use BGP as a way of building traffic engineering and tunneling type stuff, BGP carries flow spec, which lets you carry firewall rules. I just gave a talk at the recent NANOG about things that were good and bad about flow spec and like how it touches BGP. And part of the headache that we have is, again, that growth story. How do we actually better scope things so they live where they belong? How do we take the use cases that maybe are slightly strange, they happen to fit into BGP, and make sure that we can still use all the same tools, but without actually necessarily limiting the scope of BGP's growth versus that stability of the internet case. The data center use case is an example. BGP was, you gentlemen would probably agree, is not the greatest protocol for building fabrics. but it does an excellent job for it. It's simple to implement. It has good use cases, but the challenge becomes, how do you actually make your fabrics, talk to the outside world? And that's that sort of sharp boundary when you start making one instance of BGP for an application, start talking to the other ones, and what does that do to your fault domains?
Yeah,
I would like to bring us back to one of the most fundamental issues, blast radius, right? So I'm personally to blame to bring in quite some stuff into BGP-LS from my GPs, right? Because it's convenient, it's there, kind of working. But then I've also seen a network really melting down just because BGP-LS has some issues. So we've got this, consequences of increasing blast radius while using same protocol, trying to adapt semantics of something that doesn't really, I wouldn't say doesn't belong, but questionable, right? So how do we make sure we can use BGP for another 20 years while blast radius is really increasing? Do you have view on service BGP? Do we split OPEC stuff from reachability distribution? How do we evolve?
Well, and the nice thing is a lot of these things come back to a lot of what I've been calling BGP intrinsics. At some point, somebody needs to write a draft or be a small book or something like that. That basically says, here's bits of wisdom you sort of distilled from living in BGP for the last 30 odd years, and there are things that anybody who's worked on the protocol or been an operator for long enough knows. You give them good examples. If you're going to start putting stuff into BGP and it is lending itself towards instability for whatever reason, even if what is considered instability is valid for the protocol. If you're pushing the IGP stuff in there and the IGP is flapping around, it's perfectly reasonable that BGP is going to do sort of the same thing. But that if you actually care about the convergence characteristics of it, you start having some different conversations. Like if your core use case for LS is just to get the topology, maybe you want to split that reachability of the stable stuff versus the unstable stuff, and the protocol is quite happy to pass along routes that are stable and potentially different queuing priorities. So your implementations could help you in these circumstances as long as sort of the underlying data models that you have that you're pushing into BGP can support that. So the unstable stuff, hook that off to the side. Let the stable stuff stay stable. Let the unstable stuff maybe fight for the queue.
So that's kind of philosophic approach, and you need to understand how the sausage is made, right? Practically, it's what you implement, right? So internally you can decouple, you can multi-thread, you can do many things to kind of decouple how reachability AFI affects your Kafka AFI, right?
Yeah.
But practically it doesn't change fundamentally the trend to bring more and more stuff. And I mean, BGP-LS with IGP distribution, kind of border case, because of convenience, it was there and it's working. I mean, any large network in the world today, why we are not using BGP-LS, right? However, now we are talking about bringing CPU loads, memory utilization, all kind of stuff that's highly, it's not stable. It's not stable per design by definition. So where do we go from there?
Yeah, and this fits the usual problem that we have with a lot of IETF protocols. When something has a given shape, you want to put something that roughly fits into it in there because it seems like a reasonable fit. BGP tends to get things that you want to hook onto hop by hop distribution of information. You get into the IGPs and you're tying stuff into node and link state. You look at DNS, people want to just stick extra records in there because you have a nice recursive tree that's sort of a nice distributed mechanism. You pick any of the protocols, people are going to have something that has the right shape, and it's like, why couldn't we put it in here? And that's where the intrinsics become important. BGP is quite happy to pass this stuff along. I was talking about for the instability, you have design and implementation choices you can make to try to actually bias some of your use cases. But the challenge you run into is where do you start standardizing some of those best practices? Our implementation of Juniper has a nice queuing system to allow you to separate routes based on a prioritization scheme. So if you want your LS stuff to maybe live on the same session for some strange reason as maybe flow spec, maybe you want the LS information to go ahead of it. Maybe you have use case that's modest-sized data center. You want all the things that's your next hops, your BGP labeled unicast. You want those things to get pushed to the front of the queue. You can do that. And nothing in the protocol description says how you have to build these things. It just says, here's the procedure for getting stuff in and out. But as you're saying, the core pieces are how do you actually take the network behaviors once you have this stuff running and build an ecosystem that actually respects stability versus the ability to carry extra information.
Also, at some point, most networks are multi-vendor. Even if you did it right, but someone else did it wrong, everybody is going to suffer.
Right.
So we've in ATF at least we create a lot of documents, not only how to design protocols, but also how to deploy them. I mean, the RFC 7938 BGP in large GCs is a very good example of that, right? It has become a Bible of pretty much, generation of network engineers who've been building data centers for the last 5-7 years.
Right.
They just pretty much copy what's there, and it works. It works in my network. My network is built. RFC 7938 was written looking at my network, right? So it works. However, looking at what you just described, there are no real guidelines. Every vendor builds whatever. Look at prefix prioritization. It's been around for 10 years. Everybody implemented it, but everybody implemented it differently, right? So even though you could download prefix priorities into RIB when they got from your peer into adjacent RIB in, suddenly there's no priority. We've seen this, right? So all the optimizations are meaningless unless it's well-defined set of optimization. Do you think there's value of standardization is not a good word for this, but at least describing them so people building open source, FRR is becoming de facto standards in many deployments. So explaining to younger generation how to build stuff properly.
Well, and there's always the headache of how much of it's secret sauce versus what you want to be standardized. If you're an operator, you want enough of the good tools that you like one vendor to be present everywhere. That's part of the usual process for getting stuff out for proposals. But rolling things back to what can we do in IETF? Prioritization we know is a thing. BGP RFC is largely silent on exactly what you do for some of these things. There's room for us to write some of these things down. That's the intrinsics that I'm talking about. And then some of them maybe start heading into that future-facing discussion in terms of what did we get sort of right that maybe is getting in the way a little bit. And one of the items I had in my presentation when I was in Oslo was BGP was based on TCP. It made sense for the guys working on it at the time. They had experience with doing EGP and having nodes fall over because they didn't have enough buffer space and some stuff. You can throw it at somebody else's code and make it reliable. Why not do that? And 30 years on, pretty much everybody that does any level of BGP and has to do any troubleshooting is always some low-level TCP expert because that's where all the headaches are biting us on things. Are we getting window congestion? Or are we getting drops? And in particular, for trying to build reliability solutions for multi-CPU things, some flavor of nonstop routing is we call in Juniper and other vendors as well. You have to worry about how do you get those windows to synchronize back and forth. And sort of one of the headaches is TCP doesn't implement an OSI layer 5. There's no sessions in there. There's no streams. Mm-hmm. And one of the headaches that we have out of this as a consequence is that the network stack and the thing that implements it can't help us do things like even frame keep alives as an example to help scale up sessions, or just as importantly, allow us to do multi-session type things where we want to have one session carrying things, and we don't want framing problems in one address family, or maybe even sets of information that we want to have different prioritizations carried in a more explicit fashion than just some vendor's queuing code. We don't have anybody to implement that sort of thing. And we're starting to see that conversation actually happen now. There's some proposals out there to run BGP over QUIC. I haven't done the deep analysis yet. That's on my to-do list. And conveniently, QUIC has some of those layer 5 properties we really like. Unfortunately, with all the TLS things that it runs in there, I think you're going to find that TLS does not necessarily live nicely with protocols that have multi-month uptimes.
So for our listeners, there's a draft that's actually called BGP over Quick that tries to do some of this analysis. If you're interested, go read it and let us know what you think.
Yeah, I've been poked by
Being
L for
part of the draft, I would be particularly interested in your opinions.
yeah. It's
But
on my
what's your personal opinion on BGP over Quick? Should we go there? Are we ready to go there? What do you think?
Well, I haven't done my homework, but the things that I'll say, and I had a chance to talk to Ying Zhen when I was traveling for Nanog. She's one of the people that's working on these portions of the plumbing for that. Is we have a lot of desires for things that we've learned about BGP that we want to see implemented. If the stack can give us that, that's great. We want the nice layer 5 type framing. We want the ability to do the multiple sessions across the given multiple streams across the given set of sessions. We want the ability to basically make all of the things about pushing PDUs and all of the lifecycle things about them a lot easier than people doing the same bang on the TCP socket things that we've been doing for 30 plus years. Because everybody that does it and has done it for a while knows some of the gotchas to look for. And as you're sort of talking about the newer stacks coming and going, they almost always get some piece of it wrong because they haven't been bitten by a specific issue. And that's, if we can have some way to take some of those problems away from them, that would be helpful.
Imagine it were up to you, and to some degree, it is up to you. By now, I would consider you a BGP elder, right? I mean, it's not about your age; it's about time you spent with BGP.
Yep.
We've done a lot of good stuff over the last couple of years. So the error handling was huge improvement. Rather than dropping session, now we can actually look what went wrong and decide, is it actually worth to send notification restart, or maybe we'll just treat it as withdrawal and nobody's hurt. We've increased size of message. We've included some metadata in notification. I can actually send you a Shakespeare poem if I wish to do so. So I would say it's more tactical than significant kind of changes in semantics protocol stuff. What do you think should happen? What would you do to make protocol better? And again, better is up to you how you define it.
Yeah, and that depends on the part of the slides that I wrote that basically is like, what would we do if we were writing BGP from scratch today? And having those conversations about the transport session up front and trying to figure out how to bound the headaches that you have is a big portion of it. How do we make sure that people don't have to be a TCP expert or whatever the new session layer protocol that we put stuff on? If they have to do deep debugging, we probably already lost. We want to make things easier, not harder. And we talked to any of our friends in IETF that work on transport, they're going to tell us this stuff's hard. So there's no easy out on it. Security is a big deal. It simply wasn't built in up front. We had MD5 that got added on the TCP years ago because people figured out how to spray a few packets at a router and knock over sessions across the internet. And it's only the last roughly 2 years that we've gotten something better than MD5, and we're still not fully seeing deployment of the thing. We want to see TCP/AO in the host stacks, and Juniper and some other companies are trying to help the open source community eventually get there. But part of it is just the conversation about thinking about these sessions having long life cycles. So that's part of training the transport groups, part of training the security groups about some of the things we care about. We talked about session layers as a way to maybe help us with how do we actually provide prioritization, multiplexing, and that error handling case. If you knock over your address family that might be on a given channel, well, maybe that's not catastrophic anymore, and that's a happy thing. Interesting question eventually comes down to if you've hit certain types of catastrophic bugs, maybe multi-session and multiple streams aren't going to help you. Your implementation's gone insane. So error handling's just there to keep the lights on until you decide the box has to be knocked over and reset. But past that point, again, every one of these things is a small incremental thing. BGP's done very well one step at a time. We know that the encodings we have partially work. Path attributes, as a tupled item with a bunch of routes, that's scaled great, and there's a lot of push and a lot of the BGP work over the years to try to maintain that update packing as much as possible. But we also know that sometimes you just can't do it. We have things like BGP-Sec that are pushing us to take away packing as a feature altogether, and we have some other features that are trying to push it back in. So we're going to see a tension, I think, back and forth with that as an encoding thing. And I think one of the things that we really would like to see is clean up encoding maybe one more notch. The BGP error handling RFC did a little bit of service trying to rearrange where the NLRI were inside of the packet, but we still have encoding issues for these things. And if you can't figure out where the NLRI are versus the path attributes, or you got a corruption somewhere there, you can't really handle that. You still have to knock the session over. And figuring out ways to leverage the restart capabilities. And we have like the enhanced graceful restart type things that are there to try to hopefully let us replay less of the table. Because I think end of the day, the big headaches we're going to live with once we get the transport portions out of the story, and at least some of this in Blur, how do we pass the state around? The fundamental headaches we still have to work through as vendors, implementers, and operators is how do we actually take the state, which in the grand scheme of things is a very small amount of data, but it has an immense amount of CPU tied behind it. And the lifetime of this data, the sessions go down, a router, it's at some modest scale is going to take a while to come back up. How do we make that faster? How do we exchange less of the data? How do we basically make BGP more stable? Those are the sort of key things I think we're looking at. The rest of it's the security story of the data itself.
You had mentioned open source earlier, and Jeff T, you mentioned quite a few minutes earlier FRR. If you look at vendors like Juniper and Cisco, there's a lot, decades literally of institutional experience around building stable BGP implementations. With open source coming along, do you see that being problematic, or are the same people that are contributing to that institutional experience at established vendors contributing to something like FRR, making that also a stable implementation?
So I think that the challenging thing here is that anybody that rocks the boat a little bit is going to show you where all of your sins are hiding.
Yeah.
Somebody ships, one bad packet that's written up, in a weird way in the RFC, and you see, a cascade of failures across the internet. Well, who's at fault? The person that rocked the boat by being the new implementation, or the person that actually has been shipping the code for 20 years. So, in one respect, a thing that I think the industry as a whole is in desperate need of is good conformance suites should be out there, and they should just literally be a public resource. I'd love to see some organization like US NIST or something similar set up basically an open set of suites that everybody can run, and you can test your implementation and say that this stuff is rock solid or not. Get the important things taken care of, because the disruptions of the infrastructure can do bad things to the planet. We need to worry about that. But past simple bugs along those lines, the rest of it ends up being the tension about people wanting to add new features. Why do people actually reach for open source as part of their toolkit? Well, one part is because their application doesn't need somebody's commercial routing stack. They and in many cases, they want to do something clever with it, and that's great. It means that the protocol has attraction for them. They want to actually do things with it. They want to actually help build the next piece of the network. And a lot of cases, these things end up driving use cases at the big commercial vendors too. So that's a happy thing. But the challenge that we have is that a bit of the culture that the open source stacks have to navigate, and many of them do it very well, is participating in standards. Code points are a scarce resource. They're thankfully being allocated in a mostly wise fashion. Occasionally, even the commercial vendors do bad things and ship stuff where they haven't properly allocated these things. And really one of the headaches, and this is again back to what are incremental things. Back in 1994, we're figuring out how many octets a BGP path attribute should use for its type code. 255 of these things. We should never run out of them. And 30 years on, we haven't actually gone through all that many. So we're not in danger of losing them anytime soon, but part of the conversation that we've heavily seen in IDR and all the other BGP related work across the IETF is how do we actually let people build their experimental playgrounds without necessarily having the opportunity to crash other people, and how do you actually encourage them to build the solid stacks that, if the routes happen to get in the internet at large, do happy things. That's the only tools we have right now is try to walk people through how IETF process works, try to make it easy for them to grab code points, and then past that point, it's don't trust anybody. Assume that they're trying to knock your implementation over, and have good safety knobs on it.
A bit of PR. So upcoming IETF is in 2 weeks, and we're actually having people from University of Roma presenting their routing suite testing framework at routing working group meeting. Tamaza and few more friends are going to talk about it. We will eventually also invite them here. So Jeff mentioned that we are in bad need for well-designed testing suite. That could be the first good step. It's open source and it shows really, really great results. So please join us at routing working group meeting at IETF 114 and see the presentation. If you cannot join line, obviously all IETF meetings are on YouTube. So go watch it, and we'll come back on this topic more.
Yep, I'm looking forward to that. That's a tool we've been in need of.
So looking at what you said about features coming from open source, I think a numbered interface is one of those very good examples, right? Mm-hmm. Cumulus built it, everybody loved it, and now everyone has implemented it. Do you think it's a viable way of accelerating feature development that could benefit simplicity or better approaches to configuring and managing stuff?
Yeah, I think that's a good example. If you're talking about the unnumbered PHP peers, basically. Yeah, so that's a great example. Pretty much every commercial vendor has some flavor of that feature right now. But the problem was there are enough sort of edge cases in the original v6 spec as to what does your next tops look like, that sort of thing, that we have interop problems. And this is an interesting example of there's only so many ways to build this. Almost everybody had their own flavor, and for the most part, people added in knobs to try to work around other people's interop issues. And at this point, they're now coming back to IETF saying, hey, we'd like to actually standardize this stuff. There's been 2 or 3 drafts in the last year and a half trying to do this, and I think IDR just needs to effectively pick a set of editors, and let's actually get something fully standardized. We have deployment experience before we have no formal RFC, so that hopefully means the process should go pretty quick. So it's a great example.
It looks like in this case, we're actually going to IETF ground principle running code, right? So in this case, Cumulus or whoever else builds its features into FRR that led to standardization, informal standardization. There is still no formal RFC for that. And now it actually works across vendors. So maybe this is something we should consider for, running code and doing stuff right, rather than, I'm not going to go into whole discussion about encoding of color communities and what's going on right now in IETF. Topic for another meeting. Practically, we see very common theme. 2 largest vendor build stuff that doesn't interrupt together, and both have customers using it, and we end up involved cut in half pretty much.
Yeah.
Yep, and that's a longer conversation, but just sticking with the autoconfig stuff, we're talking about unnumbered links. That's great, and we also know that there is a whole bunch of different auto configuration style features that are out there. And this is a case of the BGP ecosystem continuing to expand. We have people wanting to use BGP in easy mode. Why would you want to spend all your time worrying about your addressing schemes for bringing up links? You want to make that piece just sort of on the easy style of things. And we had a sort of the counter of what you're saying, going through the BGP autoconfig work the last roughly year and a half. We have a whole bunch of proposals that got thrown out when people thought autoconfig might be a good idea, and everybody sort of stood behind their own idea without necessarily saying, we're willing to pick one. So right now, we're in a let the market decide type situation, is my guess is where it's going to land. The nice thing is we've gone through enough of the process that people can talk about this as a landscape, and where I expect it to actually get settled is we have operators that have features that they want to use, unnumbered links, couple that up with auto discovery of some flavor, couple that up with some flavor of roles, things that we actually see from like the security work around BGP open policy. Imagine a flavor of that for your fabrics. You get the point where if you're the style of operator that wants to build fabric with basically very little configuration, this becomes an easy to do things. But we're sort of also competing against operators that have operationalized their entire provisioning system so that they unit test every single layer. These autoconfig things don't necessarily help them. So really, this is tools for the next generation.
Yeah, I'm not going to talk about my data center, but I remember Igor Grushinsky from Yahoo standing up and saying, if you think I need to auto-configure anything in my network, you must be insane.
Exactly. And some of these things also fall back to telemetry type features.
Yeah.
It's like your boxes, knowing what the roles are should be able to also tell you what's wrong with them.
Let's switch gears and move to another topic, which is one of favorite BGP discussion here, is BGP security.
Yes. That's the last thing on the roadmap that we're talking about.
Yes. So RPKI is progressing. We see every week new announcement. Last week was Orange that has fully implemented RPKI everywhere on the edges. So I hope in year 2, we won't see routes without routes, right? But this goes so far. Good first steps. From my point of view, it's not even RPKI itself as discipline to get people to register their stuff. Long term is probably much more important than the semantics, what you do with it. But so RPKI is done or in process of being done. What are the next steps? We are talking about assigning different roles. There's work on there's a lot of work going on, but somehow, there's no consensus of what are the next steps. BGP-Sec requires forklift upgrades on hardware, so it's a difficult discussion. Our government, US government, got really, really worried about what's going on with BGP recently. What do you think? How do we progress from where we are today?
Well, conveniently, this is one of those, if you're building in the stuff from the start and designing what the internet should be, we would have had these questions answered a long time ago. But what we've actually seen over the life of BGP is, I'm going to pick on Curtis, back in the days of ANS and AOL, being very picky about what routes they accept via the internet routing registries. And that's an example that people decided to use policy to solve these problems. And what we're sort of looking at is policy as a external application, and more as a distributed database. The IRR had most of the right ideas that we wanted. It even had some security mechanisms defined that weren't deployed for some of this stuff. But the fit was not great. And what we're seeing is a steady evolution towards here's the attack cases, for at least the internet. I'm worried about my prefixes being hijacked. I'm worried about routing misannouncements causing bad transitivity, even though it's valid BGP topology, it's not a valid business topology. So we're down a nice trajectory right now for the features. RPKI as a thing isn't done, but it's the origin validation tools that we have from RPKI are getting great deployment, and that's a very happy thing. So that's going to get us out of the accidental misorigination cases that are a truly important thing for a lot of this internet security landscape. BGP open policy is finishing up and should be popping out the RFC gates very soon now. And again, another great idea, taking some of the standard Gow-Rexford style Valley-free BGP routing, getting that embedded as a simple piece of plumbing that you can configure in your peers, and you don't have to worry about your policy quite so much to enforce that. So that helps, again, some of these accident cases. And the ASPA stuff, and the ASPA stuff has some controversy still around it, but it's again back to existing BGP operational business practices. It's about routing the money. For the most part, if you're a BGP operator, you care about your customer codes, and having a way to formally describe those things and have policy plumbing that can help you enforce those things, either directly or transitively, is a helpful thing. So, that's going to be the next piece that we see as a push for, especially the RPKI as a general database. The trouble with all these things is that, while these can help you, especially for accidents, where in a land where there's concerns about people doing intentional route hijacking, actually doing bad things on purpose. And the plumbing that we've just talked about can help an awful lot of those cases, especially if you're closer towards what's perceived to be a source of truth. But that depends whether or not you can trust it. It's like if you're, as I was talking to some people at the most recent NANOC, if you get a brand new contract for a customer and they claim to be specific AS, how do you know that they're actually that AS? And the operators have come up with some very clever procedural things that try to actually prove that. And those are things that are starting to get formalized as operational procedures. But those things eventually have to tie into BGP policies, because sometimes either the direct customer or sometimes the peer itself has malicious intent. So we start eventually getting into the sense of BGP routing state does need some level of signature on top of it. The guys that worked in BGP-Second over the years did a very nice job formalizing what signing paths would actually do for you. Problem, as we know, is that it's not really deployable in terms of it's doesn't scale nicely. It has high CPU impacts. There's papers out there talking about how we could potentially reduce these things. There's discussions about how we can apply specific crypto acceleration techniques. But since BGP is about incremental deployment, this means that as we start filling in that piece of the landscape, we're not going to see that as something that can help us in the short order. What I'm expecting is the next piece. We have origin validation. We have ASPA to help us with AS graphs. We have open policy to help us with individual roles. We're probably going to see 20P likes to call the closed user group type scenarios. The internet, theoretically, you're talking to everybody. Theoretically, there's the end-to-end principle. In practice, we know, and we've got people like CADA and other organizations helping us provide the modeling for the fact that the internet really isn't truly end-to-end. And your security story is the same sort of way. It's like if you happen to be peering with a specific tier 1 ISP, as long as you trust their scenario for their directly attached customers, you can't necessarily prove that without something like BGP-Sec. But as Russ White likes to point out, anytime any sort of BGP signature pops up, just because I've told you that this route goes this direction, the minute that AS grabs that traffic, how do you know where it really goes? So once you start questioning the security of how the traffic is forwarded, much less how it's actually signaled, in terms of its routing, you have to decide, who do you trust? How do you actually build those groups of trustworthy providers that you're willing to trust the forwarding of based on the routing vicinity?
Yeah, so there have been discussions among hyperscalers and few large tier ones, at least, to start building. I mean, people actually, we can afford to do this, right? To build some limited BGP-Sec where you don't advertise full internet table, where you don't care about update packing, but this is not going to help internet-wide. So question to you, do you think we should enhance BGP and enhance in-band signaling, providing more metadata, more details about type of peerings, or focus on management of the stuff, which is IRRs and governments that getting really worried about BGP security and saying, unless you do this particular number of things to BGP, you're not allowed to carry our traffic. What do you think would be the most efficient way to enforce better security?
Yeah, the problem is there's enforcement. There's also trust involved here. It's like enforcement effectively can look like policy when you look at it through a specific lens. And for the data that's being passed around, how do you know that you can trust it? If it's somebody that's directly attached to you and you've done the necessary homework to say that this truly is the provider in question, there's a level of trust. But just like any of our formal proofs, we have to figure out what that N+1 step looks like. If I'm 2 hops away from that originator, how do I decide that I'm going to trust them? Each BSEC, again, will give us a sense of this is actually passed through a set of routers theoretically owned by this set of providers. How do I know that my traffic is being forwarded correctly? And trust and security comes down to what is your operational stance? Do I care about the forwarding? Is that the most critical thing I care about? In which case I now have a further layer of how to actually secure the underlying traffic end to end. Do I care about, these organizations are within a specific, AS cone, whether it's necessarily customer style cone, or maybe it's regionalized. Maybe you are concerned about a cluster of state actors that you don't want your traffic to pass through them. How do you actually know that the traffic, the routing says it's not going to touch them? How do you know the traffic actually does that sort of thing? So trying to actually have that conversation with people that are concerned about what's available in the tooling, what routing can tell you, and what forwarding actually can do, ends up being a very complicated discussion. And I think one of the other bits of discussion that we're going to see more of as we start continuing through these things. RPKI is a very standard hierarchical, PKIX, enforced database. You have to trust, the hierarchy. We've already seen in the news, due to the current world incidents, of people calling for certain nations to have their stuff de-peered, their certificates removed, things get expired. The original discussion point for RPKI was calling this the Dutch court attacks. Some concern that you can go to, the Netherlands and then request that right remove, some set of resources from their database. And once you've actually decided this is what you trust, you're also putting trust into that entire hierarchy, all the way up the chain.
Yeah. So I'll try to summarize unless Jeff has other questions. Jeff Doyle. So Jeff, imagine you're the product manager of BGP and it's in your hands. What would be your 1, 2, 3, 4 priorities if you were?
Thankfully, I get to have some say in this conversation. Performance and stability are the biggest things that we care about. So we're seeing, ongoing discussions over and over again about how do we actually provide some stability of sessions, stability of data, and what do we do when we actually lose sessions. So those prioritization discussions are very important and happen over and over again. It'd be nice to see some level of IETF discussion on these things, but again, there's different motivations for doing things. So how much of it is able to be standardized is going to be an interesting question. Security of routing state. I think that all the features we were talking about, excluding BGP-Sec, are excellent things, and we should be investing in them. Juniper is an example of long deployed origin validation, and we have projects in place to work on open policy and ASPA. No specific dates on those yet, but they have worth, and we're supporting the work in IETF for ASPA, trying to figure out how that's going to resolve. We're also looking at the transport discussions. Again, back to that session stability and scaling. How do we actually make BGP better by doing things at the transport layer? I think that that conversation is going to be very interesting because as much as I think QUIC has a lot of the properties we're looking for, the fact that it sits on top of TLS makes our story a lot more complicated. And that piece of the conversation needs to shake out. And maybe an interesting discussion is, does that actually change the nature of QUIC, and we end up with a profile that's better suited for protocols that have timing considerations like BGP and long-lived session considerations as well. So I think that's my top set of priorities.
Jeff.
All right. Well, it looks like we're right around stopping time here. Jeff, thanks so much for joining us. This has been a good conversation, and it seems like the last few weeks we've been focused on ISIS, but it's great to get back to a real protocol. But but anyway, thank you so much for joining us, and to our audience, thank you for joining us. Please be sure to subscribe on the YouTube channel if you want to be sure that you never miss one of our sessions, and like us on Facebook. And so, Jeff T, thanks again, and we'll see you in a couple of weeks.
Thanks, everyone. Thanks, Jeffrey. It's really great meeting. And just to add to that, we've mentioned ASPA a number of times. I think we really need to expand on that. So expect of us to invite co-authors of ASPA draft to talk about in details what it does, why it does what it does. So stay tuned, and thanks. Take care.
Thanks, everyone.